Hello. Testing, testing. Is this working? Oh, wait. Hello? Hello? Oh, that's weird. Why are you not working? Hello? Hello? That's strange. Hello? Okay, so I guess we'll get started. The first thing, there's an announcement. If you haven't seen it yet, or if you don't read your email for whatever reason, the labs are supposed to be in Jeffrey 155. This week, they're online. So you should have received a Teams invite, I hope, last night, for each of the 5 lab sections. Now, because they're online, I don't care which version of the lab you come to, right? You can show up for whatever lab you want to. Next week, hopefully, we'll get the Jeffrey issue sorted out, and we'll be back. We'll be physically in the lab. But this week, they're online, okay? Everybody, you did get an email from me, right? Yes? Okay. Also, Friday's recording, some of you, I think, don't know still. So the Friday live stream, the audio cut out. So there's a video. A video was posted on Friday, so I re-recorded it at home. And a video was posted on the website, on the OnQ site. Okay, any questions so far? Great. So picking off where we left off from last class. So I'm just gonna, again, I'm just going through the basics of the Java language, right? So today we're doing some double arithmetic, I think, and we're doing, what else are we doing? We're doing some conditional statements. Okay, so in Python, if you're going to use a floating point number, then you just type in like 1.5 and Python gives you a float, right? In Java, the corresponding type for float is double. Now, what you have to be careful about is that in Java, there's also a type called float, right? Normally, you want to use double. So double is the one that most closely corresponds to Python's float. Right, so it's the routine. It's the normal choice for routine calculations involving floating point values. Right, anything that has a decimal place in it, basically. So here, I've got a variable called high. Right, it's assigned the value double.max value. That's a very, very big number. It's something like 10 to the. Well, I don't remember anymore. It's an enormous number. Right, low. So the most negative number you can have is just the negative of high. Right, so it's not like integer, right? So for ints, low and high are different, right? So they're not symmetric. So low is not equal to minus high for integers. For doubles, they are. Now, if you want what's called the smallest possible positive value, that's double min value. So that's the other thing you have to be careful about, right? So for ints, max value is the largest positive value. Min value is the largest in magnitude negative value, right? For doubles, min value is now the smallest positive value. So this is a very, 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 very small number. Whenever you write down a number in Java as a literal, so whenever you write down a number that has a decimal place in it, Java considers that to be a double literal, right? So a number that you can write down, unless it ends with an F or a capital F or a little f. So the F's are used to indicate a float literal, right? Float's a smaller version of double, so it has a smaller range. If you try to write down a literal that's bigger than double can represent, you get a compile time error. Right? So here's some examples of some literals. Right? So x is the value 1.0. Right? You don't need the 0. You can just write 2 point. Right? You'll find that in most cases, if you just write 2, that also works because it's an int, and Java will happily convert an int to a double. You are, like the ints, you're allowed underscores, right? So if you have a really long literal that you need to write down, you can put in an underscore between digits to make it a little easier to read, right? And then there's this thing called scientific notation. Okay, so both of these things represent the value 1,000,000.99, right? In scientific notation, that e means times 10 to the power. Right? So that's 1.000000099 times 10 to the 6. Right? So that's what scientific notation is. Python has the same thing. So whoever taught you Python should have shown you that as well. But in Python, you can write down the exact same thing. Right? So once again, that's just whatever in front times 10 to the power 6. Right? And of course, the power can be negative. The power has to be an integer value in this notation. Right, so you can't use fractional powers if you're using scientific notation. Okay, sorry, I'm just going to check if the live stream is still working, because now it's, I really don't want to re-record the videos all the time. Okay, sorry, I'm just going to check if the live stream is. Okay, so it's working. All right, like int, if you do any arithmetic with 2 double values, you get back a double value. Okay, there's no conversion to anything else in Java. Right? So all of these results, none of these are surprising, I don't think. Right? So if you have 1, 3, and 13, if you add the 1 and the 3, you get 4. Right? No big surprise there. Right? The operators are the same as in Python, with the exception that there's no exponentiation and there's no // so there's no floor division in Java. Right? And all these, everything else is the same. Right? So arithmetic is just like you would do in Python. Okay, now the difference between the floats or the floating point types and the integer types in Java is if you do a floating point calculation and the value doesn't fit in the range of double, well, in this case, in the range of double, right? Then you don't wrap around, right? So remember with int values, if you exceeded integer max value, you wrapped around back to the other side, right? So you wrapped around to integer min value. Similarly, if you go beyond integer min value, it wraps around to integer max value. Doubles don't do that. So they double values saturate at positive infinity and negative infinity. Saturate means the result becomes double positive infinity, and that's it. Right? You can't go any higher than that. Right? So if you take 10 to the power 200 times 10 to the power 200, that's bigger than double dot max value. Right? So you end up with the answer double positive infinity. And then there's a whole bunch of rules regarding what arithmetic with infinity looks like, right? I'm not going to ask you about it. It's in the notebooks if you want to know about it, right? But you're not going to get any questions on it, right? It's a fairly obscure part of of working with floating point types. At some point in time, you should read about it and learn about it to see what happens when you deal with these strange floating point types. But for the purposes of testing and stuff like that, I'm not going to ask you about it. Okay, functions. So Python has user-defined functions, right? You all know that you write def max2, you get a function called max2, right? You know in Python that this function has 2 parameters, right? And you should know that a function is just what's called a procedure. Sometimes it's called something else, right? It's just a procedure that can be called to perform a specific task, right? The reason you write these things is so that you don't have to duplicate the code inside the function over and over and over again. Right? So this is a very weird implementation of max2. Okay? So this is max2 is supposed to find the maximum of two values, a and b. Right? And for our purposes, we're going to assume that they're ints. Okay? So this function assumes that a and b are integer values, and it's going to find the maximum of the two. Right? So it's a weird implementation, right? Most of you would write this with an if statement, I'm sure, or you would just call the built-in Python function max, right? But here I'm writing it as a plus b plus absolute value a minus b, right? And my claim is that this works, and you can derive this mathematically. I kind of want to write it on the blackboard, but the people on the live stream aren't going to see it. Right? The reason this works is because if you take the max of a and b and then add the min of a and b, right? So if you take the larger value and add the smaller value, that's just equal to a plus b, right? Because the max of a and b must be one of a and b, and the min must be the other one, right? So the sum is just that. If you take the difference, right? You should work out what that is. Right? And then when you add these together, right? So I'm going to leave that for now. If you add these two things together, you get 2 times the max of a and b. Right? Because those cancel. Right? So if you divide that by 2, you get the max of a and b. Right? That's just the absolute value of a minus b. Right there. Right? So the max of a, b minus the min is just the distance between them. Right? The distance between a and b is just the absolute value of a minus b. And that's it. So that's why that works. Right? There is a reason why I'm giving you this very strange implementation. Okay. Now, Java has no functions. Right? So a function, back up one. In Python, you can stick that function in a module somewhere, right? So you can call it mymodule.py. Then you can make a second module somewhere else, right? Or just you just make a Python script, right? And inside that other Python script, you can import that function and then call it like that. Oops, sorry. Okay. In Java, there are no functions, right? So there's no standalone. You can't write a standalone function in Java because everything in Java belongs in a class, right? So the closest analog you have in Java is something called a public static method, right? Don't worry what the words public and static mean for now. So it's a public static method, right? So it's not called a function in Java, although it behaves exactly like one, more or less, right? So a method is similar to a function, right? Except it's defined inside of a class or something called an interface. So if I want to define this max2 method in Java, I need a class of some kind. Right? So I'm just calling my class lecture2 in this case. Right? Notice class name begins with a capital letter. Right? I have a method. Right? So it reads public static int max2 int a int b. Right? So the part max2 int a int b, that looks a lot like the Python. Right? Except that parameters in Java have to have types. Right? The code inside looks pretty similar. Right? So I have a local variable called twice max. Right? It's a variable in Python. I have to give it a type, so it's going to be int. Right? And it's a plus b plus. Now I need the absolute value. So the absolute value in in Java, again, there's no functions. Right? So I need to find a method somewhere that can compute the absolute value for me. So it happens to be defined in a class called math. Right? And the function name happens to be called ABS. Right? Otherwise, it behaves the same as the Python ABS function. And then you can return twice max divided by 2. Okay? So similar, but there are differences that you have to be aware of. For now, every time you write a method, just slap public static in front of it. And later on, I'll explain exactly what these mean. Or you can read ahead in the notebooks. Right? Or you can use Google or whatever you want to do. I think I tell you a little bit about it later. Okay. Now, if I want to call this max2 method from somewhere else, right? What you have to do is you have to import the class that contains the method, right? So somewhere I have to write import lecture. So at the top of the class, I have to write import lecture2, right? So this is a separate class. It's a separate file. It lives somewhere else, right? I'm going to call this class test lecture2 because all I'm going to do is call the max2 method. Right? It's going to have a static. It's going to have a main method so I can run the program, right? And to call the method, right, you use the class name, right? So lecture2 because that's where the max method is living, right? Back up one slide, right? Max2 is inside the class lecture2, so I have to say lecture2 dot max2, right? The lecture2 dot tells the Java compiler that the method lives inside the lecture2 class. Right? Dot max2, right? And then you pass it into appropriate arguments, right? So here I pass in 5 and minus 3. Okay, any questions so far? All right. Sorry. Right. So there are some differences, right, in the way you define the function. The method. Right. The method has to be in its own class. The syntax is a little different, right? The code is a little different, but it's if you read it, it should be like you should be able to read it, given that you know Python. Right. To call the method, it's a little more complicated, right? If you're calling it from outside the class that the method is defined in, you have to do this import. You have to import the defining class, and then you have to call the method with the defining class name in front of it. Okay, so give me 1 second. Is this, did I lose the live stream audio again? I think I lost it again. Sorry, hang on. Oh, no, I didn't. I'm not playing the live stream. Okay. Sorry about that. Right. So what other differences did you notice between the Python function and the Java method? Right. So in Python, indentation, you know, is fundamental to the language, right? It's built into the language. You must indent where you have to, right? So when you're writing the body of a function, you've got to indent the body of the function, right? And if you don't, the Python compiler will complain, or the interpreter will complain. Right, so whenever you write the body of a function, or an if statement, or a for loop, or lots of other things in Python, you indent, right? The indentation has to be consistent, right? If you use tabs instead of space, or if you mix tabs and spaces, the interpreter will complain, right? And there's all sorts of little things you have to worry about regarding indentation. Java doesn't care, okay? So indentation doesn't matter in Java. It's only used for readability, but that's a pretty fundamental reason for using it, right? The compiler doesn't care because the compiler is not a human, right? All the compiler is doing is it's trying to interpret your program as a Java program, right? So for example, that compiles cleanly, right? There's no indentation anywhere. The spacing's all weird, right? So no indentation over here, right? There's a new line here, right? I guess I should be doing this with the pointer, sorry. Right, no indentation here. There's a new line here, right? So max2 appears on a different line. There's no indentation here. There's some weird indentation here, right? Everything's inconsistent. It's very hard to read. The compiler doesn't care, right? You should follow the examples in the slides in the course notes, right? For how to indent your code so that it's readable, right? So I went through. I mean, there's a lot of effort that's spent on the slides and in the notes. To show you code to always show you code that's a good example of that uses good style. Excuse me, that uses good style. Right. So if you're wondering what the style rules are in Java, you can just follow the notes for now. Right. Follow the notes. Follow the lecture slides. Okay. So indentation and spacing in general doesn't matter. Indentation doesn't matter. Spacing matters in exactly one spot that I can think of. So Java uses braces. So that's the other different thing, right? So because there's no indentation, you need some other way to delimit the body of a method or the body of a if statement or the body of a loop, right? So Java uses braces, right? And you can nest the braces, right? So you see here, the red braces, right, those delimit the body of the class. Inside the class body, right, there's more braces, right? So the blue braces denote the body of the method, right? You need the braces, right? If you try to write this without the braces, you'll get a compiler error. Right, so that's the difference, right? No indentation, braces to delimit blocks. Okay, so for the time being, all of our classes are public. It's not till about halfway through the course that we start talking about things that aren't public, okay? Or classes that are not public. So for now, whenever you make a class, just make it public, okay? So the public is what's called an access modifier. And an access modifier determines what other classes can see the class that you're creating. Right? If the access modifier is public, then there are no restrictions on what other classes can see the class lecture2. Right? So as long as someone knows what package this lecture2 thing the class is defined in, they can use the class. Right? So they need to know where it is still, but they can use it because it's public. Right? So that's all public means on a class. So also for the time being, all of our methods are public and static. Okay? Now, the public access modifier on a method means that the method is callable from within any other class, or any class, including lecture2. Right? So anybody that can see the lecture2 class can also see the method max2. And the static modifier means that the method is associated with the class. Right? So static means max2 belongs to the class lecture2. Right? That's what it means. And that's why you have to use the class name in addition to the method name whenever you call the static method. Right? So when I think I have this on the next slide. I don't have it on the next slide. So back here, sure, this works. No, this doesn't work, sorry. Here, right? So back here, when I went to call the max2 method, right, I had to use the name lecture2 in front because the method max2 is static. Where are we? Okay. Okay, any questions so far? All right. Parameters. So like Python, a Java method can have parameters. Unlike Python, the parameters must have types. Right? So just like variables, parameters have types. And the best way to think of a parameter is it's a variable that belongs to the method. Right? So the parameters a and b, they belong to the method max2. Right? Inside the method max2, you can use the names a and b, and they refer to the parameters a and b. Right? So the max2 has two parameters of type int. Right? You must have the types, otherwise the compiler will complain. The names of the parameters, right, a and b, they should follow the same naming conventions that you use for any other variable. Right? They should start with a lowercase letter, and they should be in lower camel case if it has a multi-word name. Methods in Java are allowed to return 0 or 1 value. Right? That's different than Python too. Right? In Python, you can return a tuple that has as many values as you want in it. Right? So a Python function could conceivably return a million different values encoded in a tuple. Right? Can't do that in Java. In Java, you return either nothing or you return exactly one value. Right? Which is sometimes extremely inconvenient. Right? The ability in Python to return lots of different values is often very useful. Now, if a method returns a value, okay, so if it says it returns a value, then if it wants to return a value, then it must say that it returns a value. Okay? And the way you do that is you put the type of the value that you want to return. Right? So the max2 method returns a value of type int. Okay? The type appears immediately before the method name with a space separating the type and the method name. Now, if a method does not return a value, right, then it returns the value void. Right? So this main is said to be a void method. Right? So you can't leave out the return type. Right? It's either void or it's some other type. right? So so the main method in Java always returns void. You're not allowed to change it if you want it to be. You're not allowed to change it if you use that as its argument. Sorry, as its parameter. Okay, now if a method returns a value, right, then there has to be a return statement in the method. Okay, and the method stops running immediately after the return statement executes. Right, so in max2, right, the last statement of the method is return something. Right, it's return blah, where blah is the value that you return. Right, so this returns whatever the value of twice max divided by 2 is. Right. Whatever value you return, right, has to be the same, or it has to be compatible with the value that the method says it returns. Right? Max2 says it returns an int, so I have to return an int. Right? Down here, if I wrote twice max divided by 2.0, that's a double because of the 0.0 on the 2. Right? And so the compiler would complain. Right? It would say, hey, you're returning a double when you said the method returns an int. Okay? And a void method has no return statement, right? So in main, we haven't written a return statement inside main, right? And that's because the method returns no value. But there's always a but, right? But you are allowed to use an empty return statement if you want to, right? So return on its own stops the method after that statement, right? So return semicolon means the method stops running immediately after the return state. Right? So you're allowed to do that if you want to. The reason you're allowed to do this in a void method is because there are cases where the method has to do something either very complicated or it does nothing at all. Right? So in those cases, you want to use an if statement to either do the complicated thing or do nothing. Right? So often you'll say, if I don't have to do the complicated thing, just return. Right? So it's useful to have an empty return statement. It's useful to have a legal empty return statement in a language. Right, OK. So that's the quick and dirty introduction to Java methods. Right? Similar to Python functions, but there are very important differences that you have to be aware of. Now, how about if statements? So you all know what an if statement is, right? In Python, an if statement lets you change the flow of, lets you change the program flow based on one or more conditions, right? So if that condition is true, you do that statement there, and then you skip to the end of the if statement, right? If that condition is not true, you go to the next else if clause, right? And you check that condition, right? If that condition is true, you do that statement, and then you jump to the end of the if statement, right? If neither of these two statements are true, the else clause executes, right? And then you jump out to the end of the if statement, right? So you can control the flow of, you can control program flow based on one or more conditions, right? You know that else and else if are optional, right? You don't have to have these in an if statement, right? Java if statements are exactly the same, but the syntax is different, right? So that's what the corresponding method looks like in Java. Notice it's a lot longer, right? So Python's quite short, Java's quite long. The reason that it's long is because I need the braces everywhere, right? So first of all, I'm going to declare the result variable, right? So remember in Java, before you do something like result equals A, right, you have to tell the compiler what is the type of result. Right? Up here, so I'm going to do it before the if statement, right? Because I need to use the name result inside the if statement. Right? I don't have to assign a value to it if I don't want to, right? But before I return the result, right? So before I return the result, I have to make sure that result is assigned a value, right? So if this if statement were missing and you just returned result, the compiler would tell you result's been uninitialized. Right? Please give it a value. OK, now the if part's the same as Python, right? So if some condition, I think I'm going to hang on just a second here. OK, so I'm going to explain all the parts in a minute, right? So that's what it looks like in Java. So I'm going to explain the parentheses. I'm going to explain the double and. Right? And I'm going to explain why result is declared at the top in a moment. Okay, in Python, you know that you can eliminate the else block if you want to, right? The else clause. You can eliminate the else if clause too, but in this method it's hard to do. Right? So I can eliminate the else clause by assuming the answer is going to be C. Right? So I'm going to assume that C is the largest of the three values. Right? Then I don't care about the else block anymore, right? The else clause. Right? So I can shorten the method a little bit by removing, I can shorten the function a little bit by removing the else. I can do the same thing in Java. Right? So instead of not initializing result, I can initialize result to the value C. Right? I can eliminate the else clause down here, and then I can return the result. Right? Compiler is happy because result has been assigned a value. Right? On the first line, it was given a value. Okay, in Java, the conditions must appear inside parentheses. Right? So when you write the condition for the if and else if clauses, right, you must place those in a pair of parentheses. Right? If you leave them out, the compiler will complain. Right? There's no colon either. I didn't put that in. Right? So the colon is not used in Java to delimitate the end of the clause. Right? Or sorry, to delimitate the end of the condition. Right? Instead, we're going to use braces. Oops. Okay. Now, if I go back a few slides here. In Python, right? So in Python, you never have to declare a variable, right? You don't have to declare a variable like you do in Java, right? I can just write result equals A, result equals B, and result equals C here. Right? I don't need at the top, I don't need to say result equals 0 or something like that, right? This works fine in Python because Python's interpreted. In Java, it's different. You have to declare the variable, right, before you can use it, right? So you have to say what its type is, you have to say what its name is, right? And that introduces a problem, okay? So Java has a notion of what's called scope, right? So the scope of a variable is the part of the code where a declared variable name is usable, right? So where can I use a variable name is the scope of that variable. In Java, the scope starts where the variable was declared, and it goes to the end of the block that the variable was declared in. Right? So remember, the braces delimit blocks in Java. Right? So for our parameters, right, A, B, and C, those are declared at the beginning of the block. You can think of them as being declared at the beginning. Right? So the scope of A, B, and C is the entire method body. Right? Anywhere in that method body, I can use the names A, B, and C. Right? And they refer to the double values that were passed into the method. Okay. When I use result, right? So when I declare result at the top, right? So double result equals C, right? The scope starts where the variable was declared, right? So it starts on the first line of the method, and it goes to the end of the block where the variable was declared, right? So where was the variable declared? Well, it was declared inside the block, right? Delimited by the braces defining the body of the method. Right? So result is also usable now everywhere from that line on. Right? What I can't do is this. Well, I can do this, but the compiler is going to complain. Right? You might be tempted to write something like this. Right? So you're going to say, well, I don't need result until I actually know what the result is. Right? So if A is greater than or equal to B and A is greater than or equal to C, I'm going to say the result is A. Right? So what you have to remember is the scope of result starts where it was first declared. Right? So it starts here, but it's limited to the block that it was defined in, right? Or declared in. So it was declared inside that block there. So it's only usable on that line, right? Or anywhere else in that, or anywhere after that in the block. Right? So that declares a variable called result, sets its value to A, and then A disappears. Result disappears. Right? It's gone after you exit this block. It doesn't exist as far as the compiler is concerned. Right? If you do the same thing in the second clause, right? Well, yes, result is now equal to B, but it's only usable inside this block. Right? So the scope is only that one line. Right? So when you reach the return statement, the compiler says, hey, there's nothing called result declared in this block. right? And that's because there isn't, right? To use result, it has to be declared somewhere inside of the block of the body method, right? And not inside of a nested block somewhere else, right? So declaring it in here means it's limited, the scope of that variable is limited to that block. Okay, does anybody have any questions about that? You have to be a little bit careful about this. So this is quite a bit of this is a fairly large difference between Java and Python, right? Python, you just make up names as you go along, right? In Java, you have to be a little bit careful about where you declare the name, and you have to be sure about, you have to remember that you have to declare a type with it as well. Okay, just let me do a live stream check. Good. All right, now, can you have more than one return statement? Yes, you can have more than one return statement, right? But you're not allowed to have any reachable code after a return statement, right? So here, instead of using this variable result, I can just return A, right? If A is bigger than B and A is bigger than C, well, A must be the largest value, so I can just return A. What you're not allowed to do is you're not allowed to put code immediately after the return statement, right? So if you put some code there, the compiler will tell you it's unreachable code and it won't compile your code, right? If A is not the largest value, then if B is the largest value, I can return B, right? Again, no code's allowed immediately after the return statement, right? And finally, if neither of these two clauses are true, then I know C must be the largest, so I can just return C. And again, you cannot have any code after that. You're not allowed any code after the return statement. Yeah? So spacing, what do you mean a spacing issue? No, it's because the return statement ends the method, right? So if you hit return A, the method stops, right? So any code immediately after the return A will never execute, right? Remember, return statement stops the method from running, right? So return A means return the value A back to the caller, and that's it. The method goes away. Right? So you can't have any code immediately after the return statement, right? Because it'll never run anyway. I don't remember what happens in Python if you have a return statement and you have code immediately after it. Does it work? It doesn't work? You get an error? I don't know if you get an error because Python's interpreted. But anyway, it's not important. Not a Python course. OK. Now, if a method returns a value, it must return a value, right? So if a method says it returns int, it has to return int. If it says it returns double, it has to return a double, right? Now, what you have to be careful about here is that your compiler will not attempt to do any logical deduction on your if statements, right? So if you look at this sequence of if statements, right? So if A is bigger than or equal to B and A is bigger than or equal to C, return A. That's good, right? Else if B is greater than or equal to A, and B is greater than or equal to C, return B, right? Makes sense. And then you have an else if instead of putting an else, right? So else if C is bigger than or equal to A, and C is bigger than or equal to B, return C, right? If you work through this logically, right? So if you apply some mathematical deduction to this, right? You will come to the conclusion that this method always returns a value, right? It must return a value. It's going to return one of A, B, or C every time, right? Because there's no way for there's no way for the method to there's no way for values of A, B, or C not to satisfy one of these three conditions, right? Your compiler doesn't do that, right? Your compiler does not look at your code and try to become a mathematician, right? All it sees is that there's an if, else if, else if, right? And it immediately concludes, right, that it might reach the red lines, right? So it does no mathematical deduction whatsoever, right? All it does is look at the structure. So if, else if, there's no else block with a return statement in it, right? That means it's, as far as the compiler is concerned, it's possible to reach these red lines, right? There's no return value on the red line. So the compiler will say, hey, you're missing a return value, right? So this is very common for new programmers to write this sort of thing, right? New programmers will often exhaustively write out all of the conditions, right? And then in Java, suddenly the compiler starts complaining and the student or the programmer wonders what's going on. In Python, this runs fine, right? If you wrote all this in Python, everything's fine as long, well, if you interpret it back to Python, everything will run fine, right? Because there's never a condition where the interpreter will not run one of those three conditions, right? But the compiler is different, right? The compiler is looking at the structure of your program and trying to determine if it's a valid Java program, right? Java says a method must return a value if it says it returns one. So the compiler concludes, well, this one might not return a value. So you have to be a little bit careful here. OK, there's no and. There's no keyword and in Java. Java uses the double ampersand for and. Right? Do not use the single ampersand. It means, it usually works, but it means something else. Sometimes it doesn't work. That's the problem, right? So when you mean logical and, use the double ampersand. Right? The reason it uses a double ampersand and not the word and is because of the history of the language, right? It inherited its syntax from C. C uses double and, the double ampersand. Right? So that's double ampersand is the same as the Python and. And if you want or, that's the double vertical bar, right? You might have trouble finding it on your keyboard. It's not a symbol that most people use a lot, right? So you have to hunt around for it. It's normally found above the return key on your keyboard, right? So that's logical or. Again, make sure you use the double bar. Do not use the single bar. The single bar works most of the time, except when it doesn't, okay? Like Python, and has higher precedence than or. Okay? So a year is a leap year if it's divisible by 400, evenly divisible by 400. Right? So if you can take a year, divide it by 400, you get no remainder, it's a leap year. Right? Otherwise, right? It's also a leap year if it's divisible by 4, but not divisible by 100. Right? So divisible by 4, but not by 100. Right? So 1900 is not a leap year, or was not a leap year, right? 2100 is not a leap year either, right? It's divisible by 4, but it is divisible by 100. So that's not a leap year, right? So a year is a leap year if it's divisible by 400. So the percent sign is Java's remainder operator, right? So take year, divide it by 400, look at the remainder, right? If the remainder is 0, then you know it's evenly divisible, right? Or, right? The year is divisible by 4, and it's not, right? So they're not equal, not divisible by 100, right? So this works fine, the way it's written, because and has higher precedence, right? So in other words, when the compiler interprets its statement, it does that and that before doing that or the rest of it, right? The and has higher precedence. Often the precedence, so it's sometimes cumbersome to remember all of the precedence rules. For and or, it's not terrible, right? But Java has a lot of operators, a lot of arithmetic operators. So if you want to be explicit about precedence, use parentheses, right? So if you want to explicitly say, look, I'm going to evaluate this and statement first, just go ahead and use parentheses. It's fine. Right? Don't go overboard. Sometimes new programmers throw parentheses everywhere, right? And then you've got like 10 levels of parentheses that you have to try to interpret, right? You want to avoid that, but you can put them in if it makes your code a little easier to read. Okay? What time is it? 11. Okay. Now, oh yeah, so this is a lot of new programmers will write this sort of thing for this kind of method, right? So it's a method that returns true or false, right? A Boolean value, right? True or false, depending on some condition, right? And an if statement is a perfectly fine way to express that idea, right? However, as you become more mature as a programmer, you should avoid doing this sort of thing, right? So what you should realize is that this is a condition up here, right? It's some compound condition. The value of the condition is either true or false, right? So you can simply return the result of the condition, right? So start training yourself to write that instead, right? Rather than using an if statement, just return the result of the condition, right? If this thing evaluates to true, it returns true, right? So it is a leap year. If that thing evaluates to false, it returns false. It's not a leap year. Right? Yes?
So with true and false, you don't have to put the capital T or capital S.
No, so in Java, true and false literals are lowercase, unlike Python, right? Yeah, unlike Python. That's another confusing thing if you're used to Python, or if you're used to Python transitioning to Java, or if you're used to Java transitioning to Python. That's a very common error to make. I think this is the last slide. One more thing. So there's one more logical operator in Java, right? That's not. Right? In Python, the operator is the word not. Right? In Java, the operator is the exclamation mark. Right? So if isLeapYear is defined in the class lecture 3, right, then I can write this sort of method here. Right? So this is a method that returns the number of days in February given some year. Right? So if it's not a leap year, right? Lecture 3 isLeapYear returns true if it's a leap year, right? Ampersand in front, the exclamation mark in front negates the value on the right-hand side, right? So if isLeapYear year is not, if year is not a leap year, right? That's what the exclamation mark means, return 28. Otherwise, return 29. Right? Obviously, you could write this as if lecture 3 is leap year, return 29, right? But I wrote it this way to make sure to show you how to use the not operator. Okay, that's pretty good. Next class is loops and arrays, and then you'll be ready for assignment 1. All right.